The plate setup that you would use in your experiment is basically just plating your cells and letting them adhere. And then basically you're going to acquire good bright field images on the Celigo, and I'll show you how to do that today. And then with those good images, I'm going to show you how to set up good segmentation parameters using the Confluence application, which if you have clumpy cells is a good application, or if they're going to get really confluent, another reason to use Confluence. Then we're going to show you how to review your data and export in CSV format, export some images, and then I'm going to show you how to save your experiment so that you can reproduce that same workflow or image set for another scan time. And then I'm going to show you how to load that back up, and in that process you can produce growth curves, and that's your proliferation. All right, so without any more explanation, let's get started. So here's your desktop. We're just going to click on the Celigo icon to start the software. The machine should already be on. So the system will initiate the software. And we're here now at the first to start tab. Basically in the upper left corner you'll see the workflow: start, scan, analyze, gate, and results. Wherever the blue is, it's inactive when it's grayed out text, but the brown tab is actually where you're located. The first thing we need to do is log in as the demo user. And then just click Login. And now it opens up to a couple more options. We can either create a new scan, view and analyze scans, or do some batch analysis or exporting. So first off, we're going to just create a new scan. So then this page turns into helping us pick out the kind of plate that we're going to image today. So the plate category, there's a drop-down list of all the different kinds of well formats the Celigo can image, from slides to 10-centimeter dishes, flasks, all the way as small as 1536 well plates. Today we're going to use a 96 well plate, and the vendor type, now there's a lot of plates out there and this list is alphabetical, we're going to use the Greiner 655090. This is a black well plate with a clear bottom. And then we'll add a plate ID or a description that we want to call our plate. So this will be unique to this plate. And then the last thing we'll do is click Load. At this point, when you click Load Plate, the stage will move out. You'll put your plate on the stage, and then you click OK. And then the stage will move back into the system. And now we'll progress over into the Scan tab. So we are coming from the Start tab and moving into the Scan tab. So this is the only tab that's available or active at this point. So the first thing we'll do here is pick the application we're going to use today. So Confluence is the first one on the list. We'll just click that. It's a single channel application. Once you pick the application, the rest of the user interface that you're looking at will update to those items you need to select. The left-hand column is all your setup parameters for the acquisition. The rectangular area here is your image display area, and then the smaller upper end right rectangular is your plate map navigation and selection area, and the small little map is your well map. For a 96 well, it takes 16 images. So now I'm going to show you how to set up to acquire good bright field images. In the upper left-hand corner, you'll see the camera controls. We'll turn on the live camera, and then we'll now navigate over to a well that is kind of in the mid-center of the plate, because this is kind of representative. It's not the edge of the plate, it's not the very center of the plate, it's the mid-center. So C4. So now you can see there's a new updated image as we navigated over there. And now we can take your mouse scroll button and scroll in. You can hold the image down and drag it around. We've got some cells here that are a little dark and out of focus. So we'll just set the illumination. So we use auto exposure and gain. So currently the pixel intensity in the background is about 90. By clicking the apply, the software will determine what the exposure should be to give you a pixel intensity background of 120 to about 150. So the camera pixel range is from 0 to 255, and we want the background to be in the middle of that range. All right, so we have our illumination set up, done. Now we're going to set the focus. So click Focus Setup. A dialog box will open up, and we will use, for this scan, Hardware Autofocus. And all we have to do is click Register Auto. The system will then move the stage up and down in Z and study the images in view and try and return the best contrast focal plane. The system will now, once it's finished, it will stop at that best contrast focal plane and register the hardware focus beams. When it's finished, you'll see the text change to registration at C4. All right, to close the dialog box, just click Focus Setup again. All right, so now we basically have registered on C4, so now you could navigate around to see other wells, and their focus will look just like this in the other wells. But before we do that, I want to change the focus just a little bit. So this is a really good image of the cells, but it's got a lot of detail, and I know that the software algorithm prefers to be a little bit fuzzier than this. You can see, I can see the nuclei. It's very punctate inside the cells. It's a very high contrast image. But this doesn't really work so well with the software algorithm, so I like to actually defocus this image a little bit and produce a more slightly blurred image. And so that's how I want my images to be acquired. So how do I change that? So I just use these up and down arrows to change the Z plane. So currently my position is at 4.672 millimeters, and I don't have any offset set. So that's what I want to change. So we'll just click on the down arrow, and if you just click it once, it moves 1 micron. And so we'll just click a couple of times, and you can see the image on the right side is getting a little bit blurrier. So what we're looking for is to have the cells with a white body and a dark blue or dark black outline. You can see that punctate nuclei has disappeared, and now we have a bright center with dark edges. This is how the software has a better time identifying the cells. So it looks like it's negative 14 microns. So I want the system to register and then apply a 17 micron negative offset. So clicking Set Offset will populate the value up into this text box. So that's telling the system to perform hardware focus and then the offset. This will give us good bright field, slightly fuzzy images. The next thing we'll want to do is select the wells that we want to acquire images on. So clicking the selection button and then just highlighting the wells you want to acquire. And then last thing we'll want to do is click Start Scan, which is in the lower right-hand corner. Okay, so now we've moved from the Scan tab over to the Analyze tab. And the images are basically being acquired. And just to show you the graphic user interface is very similar to the Scan tab, but now the left-hand column is about your analyses parameters. And you can see the Scan tab, or the Scan bar down below, is progressing to green and showing you how far you've progressed. And then the plate map on the right is filling up with green wells. These images have been acquired and saved onto the computer. And so at this point you can click on the green wells and start looking at your images. So let's look at B5. And now for the 96 well, remember it was 16 images, and in the Confluence application all of them are merged together so you can see it as a whole well. Let's turn on the graphic overlay for both the Confluence green outline and the well mask, which is yellow. So you can see that we're covering the whole well area. And let's just zoom in a little bit and see what the algorithm or identification is doing. So the well mask looks a little bit big, so we can adjust those parameters by shrinking the percent well mask. Just adjust the number and click Analyze. The software will then update the yellow orange well. And then it's a little too much, so let's make it 99.2. And then click Analyze. The software will then update those parameters. That looks much better. Okay. So let's move over to another well that maybe has some more cells in it, so we can maybe look at the texture algorithm working to identify those cells. Yep, this looks better. So basically, we're going to adjust the intensity threshold to maybe eliminate some of those vacant areas where it's being picked up as cells. From 15, which is the default value, we'll change it to 18 and then just click Analyze. And the graphic overlay in green is now being a little bit more restrictive on detecting the areas with Confluence cells. So once you're satisfied with the settings, then you click Selection and click the area between A1 that highlights all the wells in the plate, and then click Start Analysis. Now those analysis parameters will be applied to all of the wells that have been acquired. And now we've moved over from the Analyze tab to the Results tab. And we'll show you how to review your data and analysis. So currently we're looking at thumbnail views of the wells with the data being displayed on top. And so while this analysis happening, we can actually add some descriptions to our plate, and as well as our scan and our scan analysis. This is a good way for you to track unique information for your plate scans. So we'll call this experiment plate 1, and the scan will be scan 1 or time 0 or something. And so you can add this stuff in while the system is continuing to analyze the images. The data is being populated on top of all the thumbnails. So we're displaying the data as percent confluency. You can see we have a low number of 6 on the left, and we are increasing in value over to the right, so from 6% all the way up to 40%. So if you want to see the data in a different format instead of values, you can just click on the fill icon, and it will produce a black thumbnail image and then green to where the Confluence algorithm was detecting cells. So this is just a nice visualization tool for you to see how the whole well looks as well as the plate view. And just clicking fill again switches it back to the data thumbnails. Okay, so if you want to look at the high resolution image, just double click on any well that you want to view. And then the software will pull up the high resolution image in the display area, so you can grab it, drag it around, scroll in, and then as you get into a higher resolution image, the graphic overlay that identified the Confluence cell area shows up in green. And then also you can click on the fill icon like we saw earlier, and it will fill in the areas where the cell was detected with texture. And anything outside that Confluence green area or fill area is not considered confluent. The data is displayed on the left-hand column, so you can see a percent confluency. And the plate map, you can click on different wells, and the images will update on the display area. And the nice thing is you're actually in the same well location at that same zoomed-in area. All right, so let's go back to the thumbnail images or the plate view. Okay, so now we've acquired our images, analyzed it, and we like the whole process. So let's just save this experiment with this little icon on the bottom left corner. And so we'll give it a name. Confluence, bright field, 96 well. So what I want to do is save this whole process and then put the plate back in the incubator. So, whoops. Well, first I want to show you. Okay, so here's another cool way for you to grab some images for your reports. If you want to see how the graphic overlay looks and then capture that for your report. So in this high resolution view, you have your graphic overlay on, the fill on, and you want to save this type of image to your report. So then you would just turn on the different features you want to show, and then in the upper right hand corner you'll see a save icon. This basically is saving the displayed image in this rectangular area at this zoomed in level. You can save it in JPEG, TIFF, or bitmap format. We'll call it displayed image with graphic overlay. Okay, so there's another way you can save images that are of the whole well without the graphic overlay. So just click Export Images will actually save the whole well all stitched together because we have the checkbox checked. But it's not going to have the graphic overlay, so it's the true raw image. And then we'll just change the location to the desktop. Okay, so now we've shown you two different ways you can save images, one with the graphic overlays and then one with just the raw image, but it's all stitched together. Okay, so let's click back to scan to return to the plate view. Okay, here we are, same place that we were before we did the images. And now I want to close out this session and get back to the Start tab. So clicking this small little X will close this window and bring us back to the Start tab. And now my plate is still in the system, so I can eject the plate by clicking this ejection button. The stage will move out, and I can put my plate back in the incubator. Okay, so once you've got the plate and you click OK, the stage will move back in. So now what I'd like to do is pretend 24 hours later you want to acquire that same plate. So let's load that experiment. So start with creating a new scan. We'll pick the plate format or the well format, again the 96 well, and we'll pick the vendor type, which is Greiner 655090. And now from this plate ID, we're going to recall the plate name that we had before. Ooh. And so we have our plate name, and then the new feature is we're going to click the experiment that we basically created or saved. So from this drop-down menu, we'll choose Confluence Brightfield 96 well. And then click Load Plate. So now the system's going to ask us something new. Would you like to perform autofocus registration? Yes. So this will then ask, the stage will move out, we'll put the plate onto the stage, and then we'll click OK. The system will move the plate back in and start moving to that well that we focused on and begin the focus registration. The system is basically going to load all of those things that we did in the first session. So you can see that we're in the Scan tab, and on the left-hand parameter, the system, well, let's just click Snap so you can see that we have the bright field image. It looks like pretty good focus, so we have the right application, Confluence, and the illumination is bright field with the auto exposure gain, and we have a focus offset of 14, and the wells were selected appropriately, same ones that we did before. The focus looks good. So I'm happy with everything. The system performed this setup just fine. So we just hit Start Scan. There's really no more work that needs to be done there. And in the Analyze tab, you can see that the analysis settings that we adjusted before have, again, reproduced themselves here. So the well mask and the intensity threshold is all set. And then we just click Start Analysis. And we move over to the Results tab. So now at this point you can see that there aren't any thumbnail images, but if you look at the bottom half of the screen, the scanned progress bar and the analysis progress bar are both working. So we're acquiring and analyzing at the same time. So as the system saves the image, it populates a thumbnail, and as the system analyzes the image, the data thumbnail appears. So once again, let's add some descriptions to our description tabs. And we can probably fast forward just a little bit so we can get through this acquisition and analysis. We're all set. And the nice thing is, once the analysis and scanning are done, I have basically can review the data here. It's very similar to what we had before, 6 to 40. And now I can use the fill icon to show the Confluence area. Looks very similar. And then we can go back to the image display. And now the cool thing is we can toggle between the two different scans that we just did by just going through this drop-down menu where we show the two different scan times. All right, so here we're at the first scan time, and the thumbnails and the data have just updated on the display area, and the numbers look very similar, so it looks good. So it's just toggling between the two. Notice also in the progression of the workflow that the Scan tab and the Analyze tab are now accessible. So you can go back to the Scan tab or the Analyze tab if you want to create another scan or just redo the analysis. Let's export this well-level data into a CSV format by just clicking this little box. So this is the data that you would basically put in Excel and do your graphs. So we'll give it a name, Experiment 1, Plate 1, Confluence, Day 1, and maybe Scan 1, because we did 2 scans. Oh, this is the second scan. All right, so let's change to the previous scan, which is Scan 1, and save that data into a CSV format. Clicking the Export Well-Level Data. We'll give it a similar name, but just call it Scan 1. Okay, so now we've got some images and some Excel CSV files. Let's go and review them on the desktop. So here is the displayed image with the graphic overlay in that rectangular area. You can see we're in the zoomed in level. Here is the raw image that is all stitched together. You can just zoom in a little bit and you can see the high resolution image. It's like 1 micron per pixel, so it's very fine detail image, so looks good. So we'll close those out. And then we'll look at the CSV file. In the first portion of the CSV file, it's a lot of information about the plate itself, the scan ID, the user, the acquisition time, and then the next section down is your data that you would want to plot, the Confluence area measurements. Okay, so let's go back to the software, and I'm going to show you, if you've scanned a plate multiple times, how to produce growth tracking curves or your proliferation curves. So we'll draw from our demo scans that we have on all the instruments. So choose the first one, which is cell counting, Confluence, adherent cells. You can see this plate was imaged multiple times over 11 days, and each day was analyzed in the Confluence application. But it's only one scan or a plate ID. We'll just click on a scan time that's early, and then we'll just load the existing Confluence analysis. You don't even have to select it. You can just click Load Scan. It will load, and we'll move all the way over to the Results tab to start reviewing that data. And again, you can use the fill icon as a quick way of viewing what does this plate look like from the Confluence area. And here's the drop down of being able to toggle between the different time scans. As we go further in time, you can see it gets really confluent. And by moving into an earlier time point, let's double click on a well and zoom in. Let's find a couple of cells to focus our attention on. So we've got some 4 cells sitting here in the middle of the image. You can see the graphic overlay and fill icon are properly identifying the cells. And now on the plate map area, let's toggle in time at that same location and zoomed in level to see those cells grow. So this is a pretty neat feature because you can actually focus in on a couple of cells and just see in time how it's growing. So if your image doesn't come up to the high resolution, just scroll with your mouse over the image and it will update to the high resolution image. Sometimes it gets stuck because it's a lot of images. All right, there it goes. All right, this is a pretty confluent area, and the fill icon is matching the cells detected, so that looks pretty good. Now we can go back and see at time or the second day what the cells look like. We're back to those 4 cells. All right, so now let's go back to scan or look at the plate level view. And here we are. Now I want you to click in that same area. The word is called reports. So let's click on reports and we'll produce some curves. So here are all the different scans that were acquired for the plate. Just clicking on each one produces the analysis that was done, and we'll check box that's the analysis that we want to produce a curve with. So for each of those scans, we can select the checkbox. And we don't have to do all of them. We can just do maybe the first 7 or so. Once you've identified or checkboxed the ones you want, then you go up to the right, and in the drop-down menu of the selected report, find the third one, it's Confluence, and then click Generate Report. And so now every well has its own growth tracking report or proliferation curve. So you can see that it's normalized as by default, or you can click on the non-normalized. That means that whatever well in this plate has the maximum in the Y, everything else is set below that. And then clicking on the individual wells produces an individual curve on the left. And now you can export this into a CSV format by just clicking in that box. And then we'll just give it the name Confluence Growth Tracking Data. Click Save. And notice also below that area you'll see a copy chart to clipboard. If you like that graph and you want to produce that into a report, you can do that as well. Now let's review the growth tracking report in the CSV so you can see how it's laid out. All right, again, we have the plate information in the top, and then you have the doubling time and the doubling rate for the wells that were imaged and reported on. And then it starts to go into a well level report. So you can see this is B3, and you have the elapsed time and the confluence area that was reported, as well as the doubling times by hour. Okay then. So that is the same information that is displayed for each of the wells that the report was exported for. Okay, so just in review, we've showed you very simply how to acquire a one-channel bright field image in the Confluence application on the Celigo, and the focus being in a slightly blurred focus. We showed you how to set up segmentation parameters for the Confluence application, and then we reviewed the data as well as showed you how to export images and the CSV files. We showed you how to save this whole experimental process so that you could queue it up to do your second and third and fourth scans to produce growth curves or your proliferation curves. All right, so I want to say thanks for listening, everybody. If you have any questions, we'll open up the forum.
Thank you, Sarah. That was a great presentation. So as I mentioned at the beginning, if you have any questions, you can type them into the question bar. We would be happy to answer any questions you may have at this time. Also, while we give people a minute to type any questions in that they may have, I would like to remind you if there is a topic you would like to see covered, application, essay that you'd like to see in one of these training webinars, please reach out to us at support@nexalum.com. We'd be happy to incorporate those in.
My computer's acting funny, sorry.